Yes.
So first of all, welcome everyone to getting started with Apache APISX. So let me firstly briefly introduce about us, Apache Local Community Indore. So I am Aditya Sharma from ALC Indore, and we are a local group of open source and Apache enthusiasts. So we are spreading the words of Apache as well as other open source projects. So we have with us Navendu from Apache API6 community, and he will talk about API Gateway as well as Apache API6 project. Okay, across the session, if you have any questions, please use chat for your questions. And at the last, we will have a QA, and try not to unmute yourself during the session for any kind of noise. So over to you, Navendu.
Thanks, Aditya, and thank you for having me in this event from ALC Indore. I'm really looking forward to see what more events you have in the future. And welcome everyone to this session. We'll be talking about Apache APISX, which is one of the top Apache projects. And we'll be starting things from scratch. So you'll be learning about API gateways, what Apache APISX is, and how it all fits together. And I'll also talk about the project specifically and how you can contribute to this project. So without further ado, let's get started. So I'm Navendu. I'm a maintainer of Apache APISX. Formerly, I maintained a couple of Cloud Native Computing Foundation projects. And I also help newcomers in our open source by mentoring through the Google Summer of Code and the Linux Foundation mentorship program. So let's start the session by talking about monoliths and microservices. So initially, we had the monolithic application. All of your application code is packaged into a single bundle. And you have your web apps, you have your Android apps, all interacting with this giant monolith of your application. And this was quite an easy approach. Like this was the traditional way in which we built our services. So all developers worked on this giant monolithic applications, and even though it had a lot of benefits, it made a lot of things easier. It also made a lot of things really hard. So we decided to chop this monolith down into microservices. So instead of one giant monolith, we'll have multiple services, each doing its own dedicated function. And each app or each of your client applications will interact with the service that they require for the specific use case. So this means that each team can work independently on one particular service, and yet they can start and stop these services independently. They can spin up new instances of these services independently. They can scale each of these services independently, all those advantages. But this also meant that there is a lot of complexity. So your client applications usually had to send requests to multiple services to get the data they actually want. And even in this diagram, you can see how this makes things a lot more complex. And that is the point where we evolved to API gateways. So instead of each of your client applications having to interact with each of your backend services, they interact with a common service, which is called an API gateway. So your web apps, your Android applications, your iOS app, all your client applications, they are interacting with the API gateway, and the API gateway in turn interacts with your backend services. So in essence, an API gateway abstracts out your backend services so that your client applications has a single point of entry, single point to interact with. So let's look at what these API gateways are. So API gateways can be seen as the entry points. And what this means is that an API gateway is basically a software that takes a user's request. A user here is the client application. It takes their request and routes it to one or more backend services. So it takes the client applications request and it has all your services on the backend, and it routes all your requests to your backend services, and it collects the data. So the API gateway can route requests to multiple services and collect responses from multiple services, and they can combine it into a single package and deliver it back to the client application that actually made the request. And on top of that, an API gateway does a lot of things on top of just routing requests. What it does is it provides a layer for analytics, a layer for things like security, and it is the entry point into your backend infrastructure. And Apache APISIX is basically an an API gateway implementation. So there are a lot of API gateway solutions available, and Apache APISIX is one of the API gateways. It is one of the popular API gateway projects. It is hosted by the Apache Software Foundation, and it is a high performance cloud native API gateway. It has a lot of features like load balancing, Canary Release, circuit breaking, authentication, observability, and more. And everything I talk about in this talk can be found on our website, apisix.apache.org. And now let's look at API gateways in detail. Like I will try to walk you through some of the use cases, some of the different distinct use cases, so you can get an idea about what an API gateway does and how it fits into the whole your infrastructure. And I'll be talking about Apache API 6 as the gateway API example, of course. So let's start with routing. Routing is the most fundamental thing an API gateway does for you. So consider you have a client application and you are sending requests to APISIX, which is your API gateway, and you have multiple services on your backend. So if your client makes a request to the customer endpoint, uh, if you want uh, if you want to route such requests to the customer service, an API gateway can do it for you. So when a client sends a request with the customer path, the APISIX will route these requests to the customer service. And if a client makes a request to the order service, it can actually send the request to the order service, and it will get back the response from the service package into whatever format the client expects and sends it back to the client. And it also does things like you can match particular headers. Let's say if the client is a particular user of your application and the request has specific headers or specific query parameters or anything like that, the APISIX gateway can match services, match routes based on that particular key. And if for example the order request also needs to an order request also needs the payment service, it can also handle that. So instead of the client having to go to multiple services, interact with multiple services directly, it can interact with APISIX, and it will collect response from all the backend services that we need. So in this case orders, maybe you need some information about the payments as well in the orders request. You can get those requests as well. And another thing that an API gateway does is it can translate between protocols. So generally, most of your client applications expect REST API calls. So a request like this is what we normally do, but your backend services can have can communicate in any of the different protocols, right? So gRPC is quite popular within cloud native products, cloud native applications. So even if your service communicates over gRPC, APISIX can translate between gRPC and REST and handle all of those complexities for you. And for the user, it is just like a normal REST API call. And another less trivial use case of an API gateway might be authentication. So a user can make a request to APISIX, and APISIX can actually be the entity that handles user authentication. So when a user makes a request, APISIX asks the users to authenticate themselves. This can be as simple as a key value pair, JWT token, or you can go more complex and use some third-party services, Active Directories, and all that those sort of things. But in a sense, what happens is when a user is authenticated, APISIX can then tailor the APIs, tailor the response, tailor how the service interacts with the user based on that user info. So if a user has a particular level of access, APISIX can handle APISIX can handle that role control, role-based access control, and then basically provide the user with only the information he has access to. And it can also mean tailor-made responses for the particular user. And when it comes to security, an API gateway can do things like request validation. So when your client submits a request to your backend services, you expect that request to be validated. You expect that request to be non-malicious. So an APISIX, a gateway like APISIX can be the middleman and basically watch out for these requests, make sure that these requests are in the order that is expected by your backend services. So instead of your client directly talking to your backend services, which can, if it is not validated, it can cause a lot of problems. But if with this middleman, you can actually validate those requests and make sure that you only send stuff that is expected by the backend. And this helps prevent like a lot of cybersecurity attacks, like injection attacks. And it can also do stuff like IP address filtering. So which can be like which is like a less trivial, but a really a really impactful way you can protect your backend services. So basically you can blacklist or whitelist IP addresses, which can be like which can also mean like you can blacklist or whitelist based on geolocations, all sort of stuff. So IP address is just an example, but you can almost blacklist or whitelist based on any of the other request parameters, where the request is coming from, who is making these requests, and like which application is making the request, all sort of stuff. So this also prevents the upstream from having to actually manage these complexities within the application code itself. So your application developer or the person actually developing the backend services or your upstream services, they don't have to worry about all these logics. They can just focus on the business logic of their applications, and a separate entity like APISIX can handle all this stuff for them. And of course, there is traffic control. So a good API gateway needs to handle a lot of traffic, needs to make it easy for the operator to control traffic to their backend services. So one such example is rate limiting. Instead of like simply routing requests, you can also do things like rate limiting. So if the number of requests or the number of requests per second or number of concurrent requests, any sort of these parameters, if you can configure any sort of these parameters to watch out for a threshold. And if it exceeds that threshold, the API gateway can either delay the request or reject the request. I think someone's audio is on. Okay, yes. Sorry about that. So basically, yeah. So if the number of requests or the number of concurrent requests or number of requests per unit of time is greater than the threshold, the APISIX API gateway can basically either delay those requests until your backend services is fine and they can handle those requests, or they can basically reject these requests as well. So instead of so like so instead of having all this traffic directly hitting your backend services, which may not be able to handle these requests all the time, like they may not be built to handle a sudden spikes in request, sudden increase in request. So all of these can cause a lot of problems to your backend if you don't implement a proper traffic control, if you don't implement proper rate limiting. And an API gateway can abstract out all these complexities to the API gateway, and it can handle all the requests for you. And like when it comes to rate limiting, it can be intentional or unintentional. Intentionally, people might be trying to uh, uh, do attacks like DDoS attacks, denial of service attacks, or it can be unintentional. Maybe like a lot of users are concurrently trying to access your service, but your service is not equipped to handle all that. So basically, in that scenario, rate limiting can be quite helpful. And in related to that, we also need to make sure that you can release new versions of your application. You can release applications without any downtime. So if you have a new version of your particular service, you want to make sure that you swap out the versions without having the users see the effect of that. So in that scenario, having something in front of your backend applications can really be helpful. So this is an example of a Canary release. So when so you have two upstream versions. So this is version one of your services, and this is the version 2 of one of your services. So when clients make requests to APISIX, initially all traffic will be routed to your first version of your application, to your old version of your applications, and you just have the your new version ready to be receiving traffic. And initially, what we will do is you will still be sending a lot of traffic, almost 95% of your traffic to your old application, and you can route some of the traffic, let's say 5%, to your new version of the application. So what this will enable you to do is you can test your new version of your application with real traffic, and you're only sending 5% of your traffic. So even if something happens to your application, something happens, if there is some bug or if there is some issues with your new version of your application, you can find it, and the impact will not be as catastrophic as directly swapping out to a new version. So you have some traffic to your new version of your application, and you can test out your new version in this scenario. And once you do that, and once you are comfortable with your new version, you can stop sending traffic to your old version and send all traffic to your new version. And you can keep this on standby if you want to roll back to it uh, for some reason. So basically what happens here is APISIX or your API gateway implementation is handling all this logic for you. So you just have to pass in some configuration which will be automatically reloaded. So you can basically think of it as a slider. Maybe you can slowly change the slider to route traffic between different services. So APISIX can do this in real time. APISIX can do this without interruptions. That means APISIX does not need to be turned on to restarted to reflect this configuration change. And basically you can give it some configuration, and it will automatically route these traffic as per your particular requirement. And for these kind of canary deployments, you are not just limited to the actual traffic. You can also maybe uh, uh, route traffic based on your particular locations. You can route traffic uh, based on other parameters as well. Maybe like traffic from specific applications should be routed to the new version, or traffic from specific countries should be routed to the new versions. You can do all sort of stuff, all sort of complex routing as well. You can definitely check out our documentation for more on that. But like, since this is a getting started talk, I will keep everything simple. And of course, circuit breaking. Circuit breaking might also be a little bit less trivial. So this is something when it comes to microservices, is good to have have been implemented. Uh, so circuit breaking.
Sorry, can you still see my screen?
Yes.
Okay. Give me just a second.
Okay, so yes, circuit breaking is quite simple. So if you have multiple versions of the same service running on your backend, so here you have the upstream A. So upstream A is your service that does one specific functionality, and you have three different versions. You have three different instances of that particular application. These three instances are same and they do the same thing, but you have multiple instances deployed to handle a lot more traffic. So when your client make request to APISIX, it is all abstracted out. They won't know that there is three instances running behind this API gateway, but APISIX will automatically route all these APISIX will automatically route all these requests to your backend services. And when one upstream service, for whatever reason, fails, you want to make sure that no traffic is routed to that particular upstream service. And if you are routing this traffic to that upstream service, the requests won't be processed and you won't get back responses. So APISIX can identify when an upstream when your backend fails, and it can stop routing traffic to that particular backend, and it can instead route to the other two instances that are available. And APISIX will watch out for the your unhealthy backend, and if and when it turns if and when it turns healthy, APISIX will again start routing traffic to the upstream service. So yeah, APISIX abstracts out all that, and it makes your applications more resilient. It makes your applications more fault tolerant and more reliable. Finally, let's talk about monitoring and observability. So monitoring and observability is like for whatever you are doing, like you are as good as your monitoring and observability tech stack. Because without proper monitoring, you won't be able to find issues. Without proper monitoring, you won't be able to collect metrics. You won't be able to understand what is going on in the system. So if you have a proper monitoring stack, you will be able to improve your security. You will be able to improve how you use the scalability. You will be able to improve the reliability of your applications. So to put it simple, so monitoring is quite simple. So all sort of all requests from your client pass directly through APISIX, and APISIX integrates with a lot of monitoring platforms. It has its own loggers. It has its own metrics collection tools as well, but it also integrates with other applications like Prometheus. It integrates with Apache Skywalking, all sort of stuff to basically enable you to collect traces, collect logs and metrics. So being the central source where all traffic is routed through, APISIX will have a lot of access to all these networking, all this communication that is happening between your client and your upstream API. And being that central point, it makes a lot of sense to implement your observability, your monitoring system within APISIX. And APISIX also makes it a lot easier to do so as well by integrating with all these third-party applications. And yeah, so we talked about it for a long time. I hope you got an idea about what an API gateway is or what it does. So let's try and do a quick demo. I'll try to demo APISIX on Docker. So let's try that. Give me a second. Let me share my terminal. So if you go to api6.apache.org, you will find our getting started guide. So in this getting started guide, it will basically walk you through how you can set up APISIX on Docker. So Docker makes it really easy for you to spin things up and try it out on your local machine. It is really quite easy. So it makes it easy for you to spin up APISIX and discover its capabilities. But you can also run APISIX on Docker like otherwise as well. Yeah, so we'll walk through this guide, and let me just share my terminal. All right. So APISIX has a repo called APISIX Docker. You'll be able to find that in the Getting Started guide. And this basically contains a lot of Docker Compose files and Docker images that is used to spin up APISIX and other related projects. So first of all, so in this example, we'll be deploying APISIX, and we'll be using a sample application called HTTP bin, which is basically a sample backend, sample backend service. So yeah, so let's first start by installing APISIX. So we could go to CD example, and you can find this Docker Compose file. So my machine is an M1 Mac, so I need the Docker Compose file for the ARM chip. So I can just spin up APISIX by running this Docker Compose command. So it will install APISIX, the actual APISIX server, the actual data plane for APISIX, and it will also install the APISIX dashboard, which we will look at later, which is a UI for interacting with APISIX. So let's do that. And what you see here is the stuff that was installed. So you see the APISIX was installed, APISIX dashboard was installed, and you also see etcd mentioned here. So if you are familiar with Kubernetes and if you're familiar with cloud native projects, etcd is basically a distributed storage system. So instead of storing data like in a central place, what APISIX does and what a lot of other cloud native projects like Kubernetes also does is store it in etcd. So etcd is distributed by default, and it does a lot of it syncs stuff a lot easier. It abstract out all these distributed complexity out of APISIX, and basically APISIX can store its configuration in a distributed fashion. So this makes APISIX much more scalable, much more fault tolerant, since since its configuration is distributed. So we should have APISIX installed right now. So let's try running. So APISIX has an admin API. So let's try calling this API and see if it is running perfectly. So yes, so we get a response from the admin API saying that like, okay, so you have something, API6 is sending some response. So now it is empty because we haven't configured API6 yet. So we are making a request to localhost 9180 where API6 is deployed by default, and we are calling the admin API and we are accessing what services we have. We are trying to find out if we have configured any services. So these are all API6 related terminology, but let's start simple, and we will first create a route. So the goal for creating a route is when a user sends a request to API6, API6 will take that request and it will route to a different backend service. So that is what we are trying to do. So that is the basic thing you can do with an API gateway, and I'll show you how quickly you can do it with the API6 admin API. So for our example, we'll be using HTTP bin, which is a sample application. Basically, it will basically give back the same response that we sent, same data that we sent to the backend service. And it has a hosted version. So httpbin.org hosts an example of this HTTP bin application. So we can basically configure API6 to do just that. So what I did here is I created a route by calling the admin API. I pass my API key. So if I send a request with a hostname example.com with the get method to this particular address, the API6 will basically route all those requests to httpbin.org, which is our backend, which is our upstream. And yeah, so that's basically it. So we configured that, and the admin API responds back with some JSON that basically says, okay, so we have created the route you just asked us to create. And once you created that route, you can actually call the you can actually send a request to API6. So if I send a get request to API6, which is running on localhost 98, which the actual endpoint is running here, and if I pass in the path anything, and there is basically an asterisk here, which basically means anything that comes here will be taken to this path. I'll pass some random arguments just for the sake, but we are not doing anything with this argument other than the fact that HTTP will give us back the same response. So yeah, so basically this means we got a response. So basically API6 is routing to HTTP bin, and it is giving us back a response. Yeah, so whatever other technique, other JSON that came from here might be coming from HTTP bin, but the point for us to demonstrate here was how API6 can create routes, and how you can basically use the admin API to create routes. So it is just a single step. You can just simply send an HTTP request to the admin API, and you can create a route. But if you don't like working in terminal, and if you want to work with a graphical user interface, you will also remember that we deployed API6 dashboard, right? So if I go to localhost 9000, let me share. So yeah, if we go to localhost 9000, where the APISX dashboard is by default deployed, you will see how you can. It is basically a way for you to configure all these things without having to work on the terminal. So you'll see the route we just created. So we created this particular route. We created this particular route from the admin API through the terminal, but you'll see that we have this route created. But you can also create your routes through this dashboard as well without having to work on the terminal. So you can just click create. You can provide a name to the route. You can do all sort of configurations. You can provide the path. You can set the host name. You can set the HTTP method. You can also set priorities. So if multiple routes match the same request, you can set the priority. And if you click next, you can set the upstream, your backend server that is backend server that you are trying to route requests to. You can also configure that here. And you can also enable plugins. So this is where things get interesting and where APISX really shows how extensible it is. So APISX comes with a lot of plugins. So there is there are authentication plugins, there are traffic control plugins. So traffic split, setting limits to requests, all sort of stuff that I mentioned before, right? So all sort of stuff that I talked about, how API Gateway solves some of those issues. And there are also like observability plugins, which has things like Kafka loggers. We can directly enable interact with open telemetry, Prometheus, all sort of stuff. And you can also use this GUI, or for some reason the images are not loading up. Maybe it is because of my local setup. I've been trying to work some things on it, but yeah. So basically you can drag and drop these plugins. You can combine multiple plugins to achieve the result you want. Maybe you want to do some authentication and take that take the user info you get from authentication and do it for some kind of traffic routing. You do it for some kind of traffic splitting. You can also achieve that. And when you have configured your plugin, you can basically review it and submit it, and it will create a new route. And there are also other entities, other concepts that revolve around APISX called upstream, service, and consumers. And these are basically like abstractions that let you create routes, that lets you configure your APISX instance. And you can definitely go to the APISX website. There is extensive documentation regarding all this. If you go to the getting started guide, you can basically see how it all works. You can see the key concepts. You can see what all this means, and you'll be able to find the example that I just ran. And we also just started making a lot of tutorials. So based on your what you're trying to do, you can like go through this tutorial and get started. And as for installation, like the easiest way to install is by Docker, but you can also use other package managers, or you can also install it from source code. And we also have a plugin hub, which basically shows all sort of plugins that you can use with APISX. And you can also create your own plugins. So you can also create your own plugins written in native Lua language. You can use Lua, but if you are not, if you don't want to invest in Lua, hire Lua engineers or do some sort of similar stuff, you can also create plugins in Java, Go, and Python. So basically, you can write plugins in these languages, and these plugin runners, the Java, Go, and Python plugin runners, they will actually translate it so that Apache APISIX can understand what you're trying to do with that plugin. So let's go back to our slide. So I started off by talking about microservices and the cloud, right? So when it comes to Kubernetes, when it comes to cloud native technologies, where does API gateways stand? Is there something like cloud native API gateways? So right now we didn't talk about that. So when it comes to specifically Kubernetes, where does API gateway stand? So Kubernetes ingress is an alternative, or it's something that is in API gateway in Kubernetes terms, you can say. So clients make a request to your ingress, and an ingress is a Kubernetes component, and it is implemented by many implementations. And when clients make request to this ingress, it will route traffic to your services. So this is something similar to what an API gateway does. And this is exactly what Apache APISIX does with the Apache APISIX ingress controller. So the clients make requests to the APISIX ingress controller, and ingress controller is basically a wrapper around the Apache APISIX API gateway. So the ingress controller makes everything in a Kubernetes native format. So when clients make a request to the APISIX ingress controller, it will route traffic to all your services, and you can configure APISIX with Kubernetes resources. So basically, you can create a YAML file. You can install the CRDs needed, and basically use the Kubernetes ingress resource to define what your APISIX instance or what your APISIX ingress instance should look like, and basically do a kubectl apply, and it will work. And right now, a lot of people within the APISIX community and maybe in the broader Kubernetes community are working on something called the Kubernetes Gateway API. So Kubernetes Gateway API is a new project, a relatively new project that is trying to be something much bigger than the Kubernetes Ingress project, making it a lot more easier and a lot more vendor neutral to work with API gateways in Kubernetes. So Kubernetes in the Ingress API had a lot of limitations. So projects like APISIX, they created their own custom resources, own CRDs to fight that limitations, to get over that limitations. But this custom CRDs meant that it is no longer vendor neutral, and it is no longer portable. So Gateway API was a new project that is trying to solve all of this by creating a common specification for deploying API gateways in Kubernetes. So we have a couple of maintainers, Apache APISIX maintainers, actively working on the Gateway API projects and participating in this particular SIG within Kubernetes. And like we are also working to integrate APISIX with this specification. So APISIX also supports the Gateway API specification, but it is relatively new and things are always breaking. But you can definitely deploy APISIX on Kubernetes and try everything out. So if you go to the APISIX docs, you will find APISIX ingress controller docs, and it will also has a getting started guide and a lot of tutorials. So you can also check that out. So finally, I want to talk about contributing to API 6. Yeah. So first of all, why should you contribute to APISIX, or let alone APISIX, any other open source project, right? So you can improve your coding skills. Definitely working on something at this scale for projects like APISIX, which is used by a lot of people, right? A lot of people. It is handling a lot of traffic in every deployment. So or working on projects that has a lot of impact, that has this bigger scale, it will definitely help you improve your coding skills. You'll be working with top engineers from this particular field, and this will help you become a better coder. And you'll also gain real world experience, because Apache APISIX is a project that is being used in the real world on particular scenarios. So to gain that experience, you can contribute to APISIX, and the APISIX has a lot of other projects, other sibling projects. You can also contribute to that. And contributing to open source means all your work is public, and that means you get recognized for your work. You get recognized for your contribution to your open source project. And you can also build your network. So APISIX has a community, has a growing community from around the world, and you can be part of this community and build your network. And APISIX belongs to the bigger community of Apache Software Foundation, and there are communities within the Apache Software Foundation, like the one we are here today. So the Apache Local Community. So there are a lot of opportunities for you to network, a lot of opportunities for you to meet a lot of people who has the same interests as you. And with this comes new opportunities. With your public work, with your contributions, with your network, with your skills, and with your experience, you will get a lot of new opportunities. And why APISIX? It is hosted by the Apache Software Foundation, which is one of the biggest, one of the most recognized open source foundations in the world. It has been around for a really long time, and APISIX is part of the foundation, and it has a large number of users. It has nearly 10. I think it has more than 10,000 stars on GitHub. But GitHub stars is not a good metric. But we have APISIX has a large number of users. I'm always surprised by all these different use cases where people are using APISIX. So that is quite cool, and that is it is really interesting. It is really exciting and interesting to work on projects with such a variety of use cases. And being such a project, contributing to APISIX is highly impactful, and there are multiple ways you can contribute. You don't necessarily need to contribute code. Even if you are contributing code, you don't necessarily need to work on one project. There are multiple projects you can be a part. There are multiple projects within the Apache APISIX project ecosystem. There are multiple programming languages being used, so you can be highly impactful even if your skills may not seem to match initially. So how can you contribute? So there are issues tagged in the APISIX repositories with good first issues and help wanted labels. To make it easy for you to find that, you can just go to apisix.apache.org and /contribute. So if you go there, you will find a curated list of good first issues across all the APISIX projects. So there is a Python plugin runner, there is a Go plugin runner, there's a Java plugin runner. So that covers 3 languages, and APISIX uses a lot of programming languages. So Lua, if you are into front end, then there is a lot of JavaScript and TypeScript. If you are into APISIX Ingress Controller, then there is a lot of Go. But if you are interested in Kubernetes and Helm charts and Docker, there are also other projects for you as well. So there are a lot of projects. And APISIX also has the website itself. APISIX also has extensive documentation. APISIX also has a blog. So you can also contribute to APISIX by being a writer. And adding to documentation, adding to new blog post or anything like that. And this is definitely an important way you can contribute. So test APISIX and report bugs. So you can basically like after this session, you can spin up Docker on your computers. You can basically test out APISIX and see if like everything I said about APISIX is true, right? So you can test out different features. There is extensive documentation for you to look into how you can do that. And by testing this, like if you are a newcomer, if you are new to this project, and if you are testing this, you are more likely to find a lot of issues that maintainers of the project and like contributors of the project might miss. So you can report these issues. Like sometimes it might also come in documentation. Maybe something is not documented properly, so you can raise these issues. And raising issues is like an important way for you to contribute. Even if you don't end up fixing those issues, if you have raised the issues and if you have asked someone to fix that issue, then you are definitely helping the project grow and be better. And API6 has a lot of discussion channels. So if you go to API6, uh, uh, api6.apache.org and click on the community tab, you will find how you can join the API6 mailing list and also the Slack channel. So you can join in on this mailing list, and there are always discussions. You can help by being part of the release process. You can help start discussions, help run discussions around new features. You can propose new features. You can interact with other community members. You can ask for help in Slack channels, and people will like directly come in and help you. So you can do a lot of stuff. You can be part of the community. And of course, like I mentioned, there are blogs and documentation. So you can definitely contribute to that. We just have a documentation style guide. You can follow that. There are a lot of issues on the different APISIX websites, APISIX project repos that is tagged with docs or documentation. So you can basically uh, uh, comment on these issues, and uh, you can actually write and contribute to APISIX. I guess that's my talk. Yeah, it's almost an hour. So if you have questions, feel free to ask them. Feel free to uh, ask them now in chat, or like or you can come by voice, I guess. And if you have more questions, you can definitely find us on the Apache Slack channels, Apache mailing list, which I will share in the chat. Uh, so yeah, and if you want to reach out to me directly, like I'm mostly active on Twitter, so you can find me in at sudo Navendu. So my DMs are open, and like you can also reach out to me publicly, and I'll help you out with API6. So that's it. I'll just go through the comments and see if there was any questions. So Mohammed Saddam Hussein asks, do we need to have any pre-knowledge on Lua to contribute to APISIX? Not necessarily. Like I mentioned, like Lua APISIX, most of APISIX is definitely built on built using Lua. So APISIX basically uses OpenResty, so you can definitely see the APISIX architecture and see how everything ties together and why we exactly use Lua. But APISIX has a lot of other projects. So if you are interested in, let's say, if you are interested in more of the front end stuff, there is the APISIX dashboard project, which uses JavaScript and TypeScript. So you can contribute to that. And if your interest is more on Golang, there is the APISIX ingress controller. So where everything is written in Go. So you can and there are also these other plugin trainers which uses different programming languages, so you can also try that as well. Any other questions? So is Kubernetes is also an API gateway like Apache APISIX? No. So basically Kubernetes is a container orchestration platform. It takes out these Docker containers. Sorry, it can literally be any container implementation. So basically, it will take containers and it will it yeah. So it will make it. It is a way of deploying containers. And yeah, that's you can definitely check out Kubernetes project. Look, it will take a long time for me to explain what Kubernetes is, but think of it as like a container orchestration platform. Do we generally use API gateways? Yes. So if we use API gateways in some way or the other, because most of these backend stuff they generally have API gateways. So even if they don't have a feature-rich API gateway, they will generally have yeah. So we generally like a backend service that abstracts out your entire backend, uh, basically a reverse proxy. Any API, an API gateway can be a hyped up or a souped up reverse proxy. So reverse proxies are the base of what an API gateway is, and if you add more features on top, it actually becomes an API gateway, and it can handle a lot of stuff that I mentioned. What are the other gateways? I'm not quite sure what you are referring to. Uh, there might be other gateway API gateway implementations. Like the popular ones are from like the big cloud providers. So they have like their own proprietary gateways that is handling traffic to things like AWS and GCP. So there are these other gateways, other gateways, but like they are basically API gateways or like basically reverse proxies that has capabilities of an API gateway. Yeah, but mm, there could be more or less the same thing.
Any other questions? Okay. One question is how to understand large code bases, bro. Will the community help us there in any query in any query in understanding the logic? Please tell how we can go through it.
Oh, yeah. So if you go to the APISIX GitHub repository, so this is how I look at large code bases. So I'll usually go to the pull request tab. I'll I'll go to let's say some pull requests. Maybe this pull request it adds a new feature. Uh, it supports prefix mode on the proxy mirror plugin, and it has a minor change. So I'll basically see what this pull request is trying to do. Maybe first I'll read the issue description. So what this pull request is trying to fix, I will probably read that first, and I will see how it is fixed. So this is a 70-line code change, right? So it is quite small. So if I look at the code, I can see exactly where the changes are made and how these changes are being applied, how they are actually being implemented, and how they are actually and what their end result actually is. So I can go through the code and see what has changed. And this PR also has good practices. It also updates the test cases. So yeah, so that is one way to understand code bases. Start small and go through PRs and see how changes are being made. Like if you uh, try to understand the whole code base just by looking through code, it becomes quite difficult on big projects like Apache APISIX. And Apache APISIX is at least 3 years old. So there are a lot of commits. There are these many commits that you have to like something that has gone through a lot of change over the years. It is really difficult to understand what is being done. So definitely go through the pull requests and see how things are changed. Start small. Other questions or other comments, feel free to mention them in chat, or like feel free to
Navendu, there is a question.
got it. So production experience. I won't talk about like if I like, since I'm a contributor to APISIX, everything I talk about might be biased. So we have a lot of case studies. So APISIX is being used by a lot of companies, that you might know. A lot of companies, we have how they are using APISIX for really large systems, for handling like millions of users, handling high bandwidth traffic every day. So we have a lot of use cases mentioned in our blog, uh, which has tags case studies. But but the way the APISIX is designed, it makes it really it makes it really easy to make it a high availability system. So since APISIX is designed to be distributed by default, designed to be scalable by default, designed to be high performant and uh, dynamic, as in like you don't have to restart APISIX to make configuration changes. It makes it it was designed to be high performant. That was the initial goal of developing APISIX. And performance tuning, like you can do a lot of stuff. So we are currently like we are doing some major changes in how APISIX is deployed. So we are now splitting the data plane and control plane, which makes APISIX much more lighter, and you can deploy data plane instances and you can scale them independently of control plane instances. So all sort of those things are are doable with APISIX. And for challenges, there could be challenges, like for example, you could have a very niche feature that you want, but APISIX might not support that feature, and you have to create your own plugin to do that. So that there is a challenge in which like, you can have to create your own plugins, but APISIX provides the tooling. APISIX provides the platform to build those plugins yourself. So you can extend the APISIX if it is not tailored to your particular use case. You can extend it, and you can work on it. And since it is open source, like there is no limit to what you can do with APISIX. You can even contribute it back to the upstream project and let everyone else like reap the benefits of your hard work. Yeah. So all right. So you can find everything you need in our website. Definitely check it out. Definitely like contribute to it if you find anything. Like definitely, like if you are looking for an API gateway solution, definitely try out APISIX. And we also have community meetings. We also have uh, like a global community meetup, and we are also always around the world. We are at public conferences around the world. So if you are anywhere there, like feel free to stop by and like listen to our talks. And coming up next we have the APISIX Global Community Meetup, which is actually on November 22nd, I think. Maybe we'll update it on our website and on our social media, but like we have a community meeting, so you can ask questions. We'll have some educational content. We'll have some people who are actually APISIX users talk about how their experience with APISIX. We have a lot of stuff happening in the community meeting, so definitely join in. And it will always be online, and like you'll always be able to enter it without any other consequences. So yeah, definitely check it out. I guess that's it, Aditya. Like,
Okay, great. So thank you so much, Navendu, for taking your time and joining us. And thank you everyone for joining. I think we should wrap up. Great.
Thanks, everyone.
thank you. I hope to see you in the APISIX community. Yeah. Thanks.
Yeah, sure. Thanks. Thanks for the presentation and all the information, Navendu.
Thank you. Yeah, you're welcome.